This is Euclid Book 5, proposition number 17, and the proof says if you have magnitudes, they are proportional, and, well, to say it quite the way they did, boy, this was a trip here, says if magnitudes be proportional componendo, they will also be proportional separando. What does all that mean? Okay. Alright. If magnitudes are proportional and they're taken jointly, let's start up here. We have AB, which I made into a 3/4 inch line, and as you can see here, BE is a 1/2 inch, okay? AE is a 1/4 inch, BE is a 1/2 inch. BE is part of AB, okay? So what it's saying here is if the whole of AB there's a ratio being developed here. The whole of AB to BE. So let me show you that right here. AB to BE. Sorry, I'm drawing with this camera in front of me. So, AB to BE. There's the proportion there. Okay? Same thing here. You've got CF. Oh, no, I'm sorry. You've got CD to DF. CD to DF. So what you've got here is CD to DF. Just like that. Okay, that's what they're saying here. If these magnitudes are proportional taken jointly, then they are also proportional taken separately. So in other words, at some point we're going to remove the BE and we're going to remove the DF, and we're still going to have proportions. Okay? Alright. So, let's get into this proof. It says, let AB, BE, CD, and DF be magnitudes proportional taken jointly so that AB is to BE, which we've already established. AB is to BE as CD is to DF. CD, DF. We're given that immediately. Yay! Okay. Now, what we're going to try to prove, now, before I say that, what I just said in the last statement where AB is to BE as CD is to DF, that's Euclid Book 5, definition number 14. And Euclid says, I'm going to say that these things are still proportional even if they're taken separately. So AE is to EB, AE is to EB, as CF is to DF. CF is to DF. So I'll go ahead and show you the letters here. What we're going to try to prove is that AE is to EB as CF is to DF. This part is what we're going to try to prove. Okay. And Euclid makes mention of Book 5 definition number 15 on that. First thing he says is take the equal multiples GH, HK, LM, and MN. GH, HK, LM, and MN. Okay? And we're going to make GH twice the size of AE. So it's going to be a 1/2 inch line right here. And we're going to make HK twice the size of EB. Okay? And so since EB is a 1/2 inch, HK is going to be a full inch. And then what we're going to do is we're going to make LM. Okay, where's LM? LM is right here. We're going to make it twice the size of CF. CF is 1/2 inch. So this is going to be a 1 inch line here. And then we're going to make MN, which this is MN right here. We're going to make it twice the size of DF. DF is a 1-inch line, so this is going to be a 2-inch line. Alright. And then we're going to have some oddball equal multiples. And these oddball equal multiples are going to be KO, and they're going to be NP as well. Here's NP. Now KO is going to be 3 times the size, okay, of EB. Well, this is BE or EB, the way you want to say it. Well, this is a 1/2-inch line, so this is going to be 1.5 inches here. Okay. And we have NP right here, and it's going to be 3 times the size of FD. Okay. So, since FD is 1 inch, NP here is going to be 3 inches long. Okay. So far, so good. Then, since GH is the same multiple of AE as HK is of EB, okay, because we're saying that GH is twice the size of AE, and then we're also saying that HK is twice the size of EB, therefore GH is the same multiple of AE as GK of AB. Okay. Since we're saying that GH here is the same multiple of AE as HK of, here's HK, here's BE right here. Therefore GH is the same multiple of AE, okay, as GK of AB. So the whole length of GK and the whole length of AB are the same. This is the same multiple here of this as this of this. So far, so good. This is by Euclid Book 5, proposition number 1. But GH is the same multiple of AE as LM of CF. Okay. GH, same multiple of AE as LM of CF. Okay, here's your LM, here's your CF. There are twice as many CFs in LM as there are twice as many AEs in GH. Therefore, GK is the same multiple of AB as LM of CF. GK is twice as long as AB, and LM, or LM is twice as, well, of CF. Okay, so GK is twice as long as AB, LM is twice as long as CF. Got that? Again, since LM is the same multiple of CF as MN of FD, okay, LM is the same multiple of CF as MN is of FD. And here's MM. Here's MN, here's FD. Okay. Therefore, line LM is the same multiple of CS. LM, CF. That LN is a CD. LN, CD. LN is twice as long as CD. It's that simple. Again, this is by Euclid Book 5, proposition number 1. But LM was the same multiple of CF. This is twice as long as CF. That GK is of AB. GK, AB. GK is twice as long as AB. Therefore, GK is the same multiple of AB as LN is of CD. Well, GK, right here, is the same multiple of AB. It's twice as long as LN of CD. LN, of course, is twice as long as CD. Therefore, GK and LN are equal multiples of AB and CD. Okay? GK is twice as long as AB, and LN is twice as long as CD. So, GK and LN are both twice as long as the other two lines we were talking about. Again, since HK is the same multiple of EB, okay, we've got HK, right here, HK, EB. HK is twice as long as EB. And MN is, okay, where's MN? Right here, MN. And here's FD. MN is, of course, twice as long as FD. And KO is the same multiple of EB. Well, here's KO. And here's EB. And KO, we said, was 3 times as long as EB. And NP is 3 times as long as FD. Here's NP. Here's FD. You can see that NP is 3 times as long as FD. Therefore, the sum of HO is also the same multiple of EB. Okay. Sum of HO, which would be HK plus KO, these two put together, is the same multiple of EB, right here. Okay. Because we've got 3 EBs here, we got 2 EBs here, so we got 5 EBs. That MP, well, what's MP? MN plus NP makes up MP. We got 3 FDs here, we got 2 FDs here, so we got 5 FDs. Okay. So, we've got basically a 5-to-1 ratio here, and we got a 5-to-1 ratio here. And this is by Euclid Book 5, proposition number 2. And since AB is to BE, okay, AB, well here, AB to BE, we established that as a 3-to-2 ratio, believe it or not, as CD to DF. Okay, we have CD to DF, which is, of course, a 3-to-2 ratio. And of AB and CD, equal multiples GK and LN have been taken. Well, GK is an equal multiple of AB. GK is an equal multiple of AB, which is twice as long. And LN is twice as long, okay, as CD. LN is twice as long as CD. And of EB and FD, okay, you got EB appears EB, you got FD right here, okay. We have equal multiples HO and MP. Well, HO is 5 times the size of EB. HO is 5 times the size of EB. And MP is 5 times the size of FD. Here's MP, and as you can see, MP is 5 times the size of FD. Okay. Therefore, if GK is in excess of HO, okay, if GK is in excess of HO, which in this case I don't think it is. Ln is in excess of NP. If they're equal, they're equal. If they're less, they're less. Okay, so in this case, I think GK is less than HO, and in the same manner, Ln is less in size than MP. I'm pretty sure that's the case that we formed here. Okay. Now, if we had a situation where GK was in excess of HO, we would just subtract HK from each. And by doing so, we'd prove that GH was also in excess of KO. And you can do this on your own if you want to. But we saw that if GK was in excess of HO, Ln was also in excess of MP. Therefore, Ln is in excess of NP, and if Mn is subtracted from each, then Lm is in excess of NP, so that GH is in excess of KO, then Lm is also in excess of NP. You can do all this checking yourself. And we can prove all this stuff. We can prove that if GH equals KO, then Lm equals NP, and if GH is less than KO, then Lm is going to be less than NP. We can prove all of this. I'm not going to do it, but you can do it for yourself. And GH and Lm are equal multiples of AE and CF, while KO and MP are other types of equal multiples of EB and FD. Therefore, in the end, we are now going to finally be able to say that AE is to EB as CF is to FD, and this is by Euclid Book 5, definition number 5. And I think you've pretty much got the idea of how this actually works. Okay. Now, I will take a moment here. Let's measure GK. As you can see here, GK is 1.5 inches, and HO was 2.5. So as you can see here, GK was indeed smaller than HO. And so on and so forth. You can do all this extra stuff for yourself. You can make the proportion 2/3 instead of 3/2 and make this whole thing work out beautifully and that kind of thing. That's all pretty much up to you. But you've got a general idea of how this actually works. Read the proof for yourself. Play around with it. You'll enjoy it. Well, maybe you won't. I don't know. But anyway, that concludes Euclid Book 5, proposition number 17. I will tell you more in a future video. Stay tuned.